Hello students, today I am thinking that I will give a video on equivalent weight for the calculation of oxidizing and reducing agent in the redox reaction. But before that I am thinking that you need to know the concept of oxidation oxidation state to calculate the equivalent weight of oxidizing and reducing agent. So let's start some discussion about oxidation state. For this I am giving a very simple molecule, that is calcium oxide. Okay, see, calcium resides on group 2. See, calcium resides on group 2 element and it is alkaline earth metal, whereas oxygen is in group 16. Okay, it's highly electronegative. It has number of valence electron 6 valence electron, whereas in calcium it has 2 valence electron. Clear? If it lose 2 valence electron, then it will have the neighboring noble gas electronic configuration. Okay, so that is why it has a tendency to lose electron. Then that is why I will give a +2 charge. And oxygen has a tendency to gain electron. Okay, so if it gains 2 electron, then it will have the neighboring noble gas electronic configuration. So I will put -2 charge on calcium, -2 charge on oxygen atom. So this is it is known to us that calcium oxide is an ionic compound. This is ionic compound. Okay, so that is why I put +2 charge on calcium and -2 charge on oxygen atom. Clear? But if you think about H2, say this is HOH. Okay, see periodic table. See this oxygen, nitrogen, fluorine, these are highly electronegative, whereas hydrogen is electropositive atom. We know that on moving from left to right, electronegativity increases, whereas on moving from right to left, electronegativity decreases, and that is why hydrogen is electropositive and this nitrogen, oxygen, fluorines are electronegative. Clear? So oxygen, nitrogen, fluorine, they will try to hug electron. So as a result, electron density will shift towards oxygen atom. So hydrogen, you can give a delta positive charge on hydrogen, delta negative charge on oxygen, and delta plus charge of another hydrogen. Clear? And because there is a delta charge separation, that is why we can say this HO bond is polar covalent. This is polar covalent bond. Clear? So now I will introduce a new intellectual term given by chemist, that is oxidation state. So hypothetically, if we assume HO bond is polar, then what will happen? Then as hydrogen is electropositive and oxygen is electronegative, if we think that this HO bond is hypothetically ionic, then instead of delta positive charge, we'll put plus 1 charge on hydrogen and plus 1 charge on this hydrogen, and so we have to put minus 2 charge on this oxygen to maintain the electrically neutrality, because H2 is a neutral molecule. So this plus 1 minus 2 and plus 1, these are the oxidation number. These are the oxidation number. Sorry, oxidation number. Clear? So here HOH, the oxidation number of hydrogen plus 1, oxidation number of oxygen is minus 2, and oxidation number of this hydrogen is plus 1. So it maintains the electrically neutrality. Clear? Now if we can summarize this oxidation state, okay, and we know that this oxidation state is very interesting thing to explain why chemical reaction occurs. That we'll discuss later, but we have to summarize this thing whatever I have said now into in a very simple way, more simple way. That is, say, think there is a bonded B and electronegativity of A greater than electronegativity of B. So A has a tendency to hog electron density towards itself. A single bond contains 2 electrons, so these 2 electrons will shift towards oxygen. Then what will happen? Then A will get minus 1 per bond and B will get plus 1 per bond. Okay, but from using this concept, if you want to calculate the oxidation number, then we must need to know the structure of the molecule. Clear? We must need to know the structure of the molecule. Okay, and I am saying this is the best method to calculate the oxidation number of various element in the compound. Okay, why? You will know after some times. So for example, I am giving the acetone molecule H C H H C double bond O C H H H. We know the carbon is situated in the left side of the periodic table than that of oxygen. So carbon will get minus plus 2 and oxygen will get minus 2, because here there are 2 bonds. Okay, so and for this carbon there is no difference in electronegativity, so this carbon will not contribute to the oxidation number of carbon. Or here CH bond, we know hydrogen is more electropositive than that of carbon, so hydrogen will get plus 1 plus 1 plus 1 and carbon will get minus 3 total CH for 3 CH bond. Similarly here carbon will get minus 3 and hydrogen will get plus 1 plus 1 plus 1. Okay, so again I am saying that this is the best method to calculate the oxidation number, because here we have considered the chemical structure. Clear? Now I am giving another example, that is KMnO4. Now I will calculate the oxidation state of KMnO4 using two methods. First method, here see in the periodic table that potassium is in group 1 element. Okay, and obviously manganese is situated in the right side from the potassium. Clear? So and oxygen is the right side of the periodic table. So we know oxygen is highly electronegative atom, and due to group 1 element potassium will get +1 and oxygen will get -2, because potassium has a tendency to lose electron. If it lose 1 electron, then it will gain the noble gas electronic configuration. If this oxygen will gain 2 electrons, then it will have the neighboring noble gas electronic configuration. So oxygen will have the -2. Okay, so for potassium +1, manganese, let's say oxidation number of manganese is X. We are going to calculate the oxidation state of manganese, and for there are 4 oxygen, so +4 into -2. Cheminophile is electrical neutral, so total charge is 0. So +1 plus X minus 8 equal to 0 and X equal to +7. So from this method tells that my oxidation number of manganese is +7. Now I will calculate the oxidation number of manganese used from the chemical structure of MnO4-. We know KMnO4 means K plus MnO4-. Here we can consider the MnO4- only. Then Mn double bond O, double bond O, double bond O, O-. Okay, so Mn double bond O, oxygen is more electronegative than that of manganese, so for this oxygen it is +2. Here again for this Mn double bond O, another +2, this Mn double bond O, another +2, and here it is Mn single bond oxygen, that is why it is +1. So oxygen state becomes +7. So from the chemical structure, it we have seen, we just see that oxidation number of manganese is +7. Here it is also +7. So we come to the same answer. But again I am saying that this method is more correct. Why this method is more correct? Now I will discuss. That is why I am giving another example of a molecule, that is CrO5. CrO5 is electrical neutral molecule. For oxygen, obviously we know that if oxygen gains 2 electrons, it will have the neighboring noble gas electronic configuration. Again and again I am saying this thing. So for this oxygen is -2. So there is 5 oxygen, so -2 into 5. Let's say oxygen's number of chromium is X. So X, so equal to 0. So X -10 plus X equal to 0, X equal to +10. Here it is saying that oxidation state of chromium is +10. Clear? Now I will draw the structure. So chromium O, structure is very interesting. It looks like a butterfly. Clear? So this is shear double bond O. For this it is +2. Shear single bond O, this is +1, because we know that electronegativity of oxygen is more than that of chromium. For this shear single bond O, another +1. There are shear single bond O +1 and another shear single bond O, another +1. So 2 +1 +1 +1 +1, so total +6. So chemical structure says that oxidation number of chromium is +6. Clear? So this I have said that this is more correct because I have calculated it from chemical structure. Okay, so this is correct and this is wrong. That is why I am saying again and again same thing. If you want to calculate the oxidation state of a element in the compound, consider the chemical structure. You just try to know the chemical structure of various molecules, because this is very important for the understanding of chemistry. So if you like my video, then subscribe my channel. It will help my channel to grow. Thank you.